Hello everyone, welcome back to a brand new episode of You and Fire. My name is David Pixenmeister and today I want to give you an introduction about Firestore and NoSQL cloud-hosted real-time database by Firebase. Let's dive into it. To get us started, we first need to create a database in our Firebase console. So we head over to the database section, create a new Firestore. We're going to start it in test mode so we have all the read and write access. And we can see that our database is being created right now. And if we head over to the rules section, we can see that we have read and write access for every user for every document. This is good for testing and developing for now, but we definitely want to change that later on. Next, we can head over to our code base. And first of all, we're going to import the Firestore package in our Firebase app.js. And then we can initialize Firestore by calling the Firestore function on our Firebase package. And we're also going to define that we want to use timestamps in snapshots for Firestore. Otherwise, Firestore will give us a warning, so we're going to do that. And then we can expose Firestore database through the firebase.db key. As a simple showcase how we can leverage Firestore as a database, we're going to create a rudimentary posting function where we save posts to our database and retrieve them later to show them in a list. To save us some time, I already created the boilerplates in our view component. So as you can see here, we have a simple header, a create button, and a form to submit this post. As a first action, we want to toggle this form only if we hit the create button. So we're gonna add a toggle create flag and a method to toggle the form once a user clicks the create button. We're also going to add this condition or this flag to our form and define our method as a click action for our create button. And if we head over to our development server, we can see if we hit the create button, the form is shown, and once we hit the create button again, the form is hidden again. Now that we got that working, we want to link our HTML form to a view model. So we're going to create a new data object in data, which is called post, which has a title and the post itself. And we're going to link this in our form fields as a view model to the input field and the text area. And then of course we need to link the form submission to a method, which is going to be called create post, which actually is going to save our post to the database later on. As a first step, we're just logging it to the console so we can test our form before we continue in development. So let's try this right now in our form. We open up the console on our browser, we enter some text for the title and the post field, click on save, and we can see that the entire post is logged to our console. Before we actually going to implement saving and retrieving from our Firestore database, I want to give you a quick overview on the structure of Firestore. Since Firestore is a NoSQL database, it's basically structured around collections and documents. And we're just going to create sample collections, which we just call users. And in this collection, we can create a new document. So we're going to create a new user. We let Firestore automatically assign an ID for this document and just add a property called name, which we're going to assign to example. And the document is now being created. And if we click on it, we can see the fields, which is name example. And Firestore also has the concept of subcollection, which means every document can hold another collection. So we're just going to add a subcollection to our users document. So click on add collection. We're going to call this collection posts. And we are also going to add another document to this subcollection. So we're going to add a simple post, which has the title and the post property. Now that we know the overall concept of how Firestore is structured, we can go to our code and actually implement the database functionality. And we're going to use the Vuex store for that. So we're going to open up the store.js file. We're going to import our Firebase app.js, where our Firestore database is declared and initialized. And we're going to create an action to create our post. And this create post action needs the state property and the actual post, which we're going to save to our Firestore database. As shown in the example earlier, we want to save all the posts as a subcollection from a user, which means we're creating collection users. We're gonna use the Firebase authentication user ID as a document ID for the user. And on this document, we're gonna add a collection called posts, where we add our posts we retrieve through our form input. This function will return a promise, so we're gonna use JavaScript's async and await functionality to retrieve the actual reference, which is saved to Firestore. And we're just logging this reference to the console for now. We can then go to our dashboard.view component, where we actually dispatch this action at the point where we are creating the post after form submit. Now that we've done that, we can actually try it right now in our development server. So we go to our development server, we create a new post, enter something in the title, enter something in the post, click save. And then we can see that this object called document reference is logged to our console. And this is the actual document which is already saved to our Firestore database and contains the ID which was automatically created by Firestore. As a next step, we also want to clear the form after we submitted and saved it to our Firestore database. So we go into our dashboard component, and after we dispatch the action to our Vuex store, we're going to reset the post data field to an undefined title and an undefined post field again. Furthermore, we also want to show the post after we submitted it. So we're going to our Vuex store and add another mutation, which is called add post, where we add posts to our local state, and we're gonna use a simple array for that, which we add to our state object as a simple array. And in our add post mutation, we're just gonna push the post to our existing post array. So as said, we want to add new posts as soon as they're created to our post array in our local state. And to achieve that, we're going to use Firestore's real-time functionality, where we can subscribe to collection and document updates. So once a post is added to the post collection, we receive that update through our Firestore listener, which we're going to add in Firebase app.js. This listener is called onSnapshot. So every time something changes on this collection or a document is added, deleted, or updated, we're gonna receive that here in our onSnapshot function. And if we open up our development server, we can see at this point we have an error in our console. And this is because if the site loads for the first time, then our user is not defined yet. So we need to basically start this listener after our Firebase user is initialized. As you might can remember from our previous episodes, in our main.js file, we wait to initialize our Vue app after we receive an user authentication change from our Firebase authentication method, and we're going to do that here as well. So once a user is authenticated, we're gonna call a function called Firebase app.init, which is initializing these listeners. And we're going to wrap these listeners in our Firebase app.js in this init function. And if we go back to our local development server again, we can now see the snapshot logged. And it already consists of one element in this collection, which we saved our database earlier. If we take a look at the Firestore documentation, we can see we have a couple of different options how we can listen to these type of changes. For example, you can listen to new documents created, updated documents, or documents being deleted in our collection. We're just gonna copy and paste it over to our code, and for now we're only interested in documents being added. So we're gonna remove the other options. Gonna change the console logging to doc added. And to display the data in our console, we actually need to call the data function of our document to get the data displayed in our console. If we now create another post through our form, we can see that this listener is called and this new document is added, and we're just gonna try it one more time, and we can see that this document is added as well. So now if we reload our page, we can see that the listener is still triggered. And the reason for that is that the first query snapshot contains added events for all existing documents that matches the query. And this is because we're getting a set of changes that bring our query snapshot current with the initial state of our query. And this also allows us to retrieve an initial state, which we need to populate our UI, and we don't need to add any special logic for handling this initial state on our side. Now that we have some more background information on how these listeners work, we can use this listener to populate our initial data, but also to add new posts once they're saved to our Firestore database. In our Firebase app.js, we can now commit these new documents to our Vuex store. And in our dashboard component, we're going to add a computed posts property where we retrieve our posts from the Vuex store. We also want to show these posts in our dashboard, so we're going to add some functionality around this. And to do that, we're going to add a simple component which just shows the title and the post of a single post. I already have one prepared in our components directory, which is called postview.view. And to show the data of the actual post over here, we're going to add a props property, which contains our post, and it's of type object, and it's required. In our dashboard.view file, we are now going to import this post view. We're also going to add it to our components property in our view definition. And we're going to add this component as well in our HTML, where we loop through all our posts and bind our data model to our component. Last, we have to also replace our static HTML in our post view component. So we're going to replace the title with the actual post title and the post with the actual post body. Firestore has the concept that the actual data from these documents is retrieved through a data function. So this is why we call this data function on our post document. Once we go to our development server again, we can see that all the posts are already loaded. And if we're going to reload the site, we can see that the initial state is already populated from the Firebase listener. So all the initial posts are already on the site once we reload it. We can now also add another new post. So we click on the create button, we enter some title and some post. I'm really not creative at all today to enter any meaningful title or post, so let's just go with this. Once we hit save, we can see that the post is automatically added to our list of posts. That works. But there's one more thing I want to change. So I am personally not a big fan of calling functions in the view HTML. So I'm going to pre-populate the data in our add post mutation in our store.js file. And we're just going to create a new object called posts, which holds the ID of the Firestore document and the data of the document. We can now remove the data function in our post.view. So it's just post.data.title and post.data.post without the need to call a function in our view HTML. And last but not least, we also want to hide the form again after the form is submitted. So in our dashboard.view, after creating the post, we're gonna hide the form again by setting toggle grade to false. We're just gonna try that one more time in our development server. So we hit create, we enter a title and a post, click save. You can see that the form is hidden and the new post is added to our collection of posts. If we now head over to our Firebase admin console in the database section, you can see that all the posts we created earlier, they are now saved to our database. So we have the user document, and the user document has a subcollection called posts with all the posts we created earlier. Before we are actually going to deploy this, we want to adjust our security rules, of course. So let's click on the rules section. And instead of having a wildcard for every document for every user, we're gonna add 2 more rules. The first one is that only the authenticated user themselves can read and write their user documents. And the second one is that every sub-collection of the user can only be read and written by the authenticated user themselves. We also need to publish these changes. It can take up to a minute until these published changes are visible. And if we go back on our development server again and create another post after these changes are populated, we can see that it doesn't affect the current behavior because we have an authenticated user and all these posts are written to our authenticated user, which means we do have read and write permissions for the user document itself, but also for all the sub-collections of this user document. That's it for today. Thank you very much for watching. Please don't forget to leave a like on this video, subscribe to this channel. If you have any questions, leave it in the comments, or feel free to join my Slack workspace. Link is in the description. And see you all soon in the next episode of View on Fire. Bye!